What is that long-run equilibrium? What does it look like? And what is the new SRAS curve that comes out of it? So let's work through these questions one by one. So step one, we want to figure out what is the initial equilibrium and what is the initial SRAS curve. All right, so as always, the first thing we want to do is figure out what are the curves that we're working with, right? So the long-run aggregate supply curve, what is that? It's just coming out of this equation over here. So YL is equal to the growth rate of productivity, which is 2, plus 1/2 times the growth rate in capital stock, which is 4. So 2 times 1/2 times 4 is 2 plus 2. So this is the LRAS curve, all right? It's just, as always, it's just a vertical line. Long-run aggregate output is not a function of inflation. And so in the long run, our economy will just grow consistently at 4% per year. Now, given all this, what's the AD curve? So as always, whenever we have to figure out an aggregate demand curve, we start with the quantity theory of money, right? So inflation plus real growth equals growth rate in the money supply plus growth rate in the velocity of money, right? It's all familiar, right? We talked about the quantity theory. This is just same quantity theory in growth rates, the one we've been using these past few lectures. And so we just plug in numbers here. So we know the growth rate of the money supply is 5 initially. And growth rate in the velocity is 0. All right. And so just solving, we get that, as usual, we have our aggregate demand curve. It's 5 minus inflation. So as always, the aggregate demand curve tells us that aggregate demand, aggregate growth rate, is a decreasing function of inflation, right? All right, so now we have our curves. We want to figure out what is the initial equilibrium, right? So we are initially in long-run equilibrium, right? That's the key thing here. And so anytime we have long-run equilibrium, what does that mean? It means we set the aggregate demand curve equal to the long-run aggregate supply curve. All right? And so we have 5 minus rate of inflation equals long-run aggregate supply, which is 4. And now just solving for this, move this over here, we get a 1. This to this side, we get that in equilibrium, the rate of inflation, or in long-run equilibrium, the rate of inflation is 1%. And what is output in long-run equilibrium? Basically, it's going to be determined entirely by this, right? It just says that, aggregate output is going to grow at 4% per year. I don't care what the rate of inflation is. So when we're in long-run equilibrium, it's a very easy shortcut to say that equilibrium growth rate in real GDP is just long-run aggregate supply, just 4. All right? And that is the initial equilibrium. Now we want to figure out what is the initial short-run aggregate supply curve. So how do we do this? So let me just put this one over here. So the general form, remember, for the short-run aggregate supply curve is unexpected inflation so inflation above and beyond our expectations plus the long-run aggregate supply, right? And so remember, the intuition behind this is that when the actual inflation is what we expect, when our expectations are realized, this term becomes 0, and the short-run aggregate supply is just equal to long-run aggregate supply, right? Now, this term over here is easy, right? We just figured out what it was, right? This is the 4. What is this? What is expected inflation? 1. Why? So he says basically we're in the long run, and so the inflation that prevails in the long run equilibrium, what actually happens, is what we expect, right? Because that is the definition of the long run. Our expectations are realized, right? And so this is going to be a -1. And so that is the initial SRAS curve. So if we want to draw this, so we have the LRAS curve over here coming down at four. So this is real GDP growth. This is inflation. Now we can draw the AD curve. So we can put this in inverse form just by solving for P. It's not very hard. It looks pretty similar to the normal aggregate demand curve, and this is one of the joys of having a slope of 1. So up here we have 5. So that's the AD curve. So this is 1. So we already put the 4 down here. So this is long run equilibrium, and now we can just add the SRAS curve here. So this is the SRAS curve. We want the inverse. And so this is +3, right? So I'm just taking the -1 out of the parentheses, adding it to the 4. And now we just move this to this side of the equation, and we get that this is the inverse curve. So PS equals y minus 3, and so it intersects at -3. Right? And that's the initial state, right? So before I go on, any questions on where any of this comes from, where any of these curves come from? No? Okay. So next step. So we're told we have a change here, right? So basically the central bank is raising the rate of money growth to 8%, right? So now this is equal to 8. So what is the new short-run equilibrium? All right, so what's the first thing we need to do here? All right, we had a change in the rate of money growth. What's the first thing we have to figure out? What's the first thing we figured out up here? Well, technically the first thing we figured out was LRAS, but that's not changing. So the long-run aggregate supply curve is not going to change unless there's some shock to productivity or the growth rate of capital stock. But what is changing is the aggregate demand curve. So the first thing you want to do when there's a change in the economy is figure out what has happened to your curves. So if it's just a change in the rate of money growth, we know LRAS is unchanged. So that's lovely. We don't have to figure out what that is. But we know from the quantity theory of money, right, that the growth rate of the money supply appears in the aggregate demand curve. So we have a new aggregate demand curve, and we have to figure out what that is. So what is AD? Let's write down the quantity theory again. And so we have an 8 here. This is still 0. And so just solving. Right, so this is the new AD curve. I'll put a 2 down here just to say that it's different from the earlier one. All right? What about the SRAS curve? So the key thing is this is in the short run. And so in the short run, expectations have not yet adjusted. And so when it says the short run here, in the face of an aggregate demand shock, since the expectations haven't adjusted, SRAS is, so these haven't changed yet. And so the SRAS curve is still this, right? Right, this is still the same SRAS curve because we're in the short run. Right? So given that, what is short-run equilibrium, right? We're asked to find the new short-run equilibrium. And so the term short-run is what clues us off. To find the short-run equilibrium, we just set the aggregate demand equal to the short-run aggregate supply curve, right? That's the difference between short-run equilibrium and long-run equilibrium. And so this side of the equation is the same as what we had up above, right? So if you'd gone up here, by the way, and plugged in, instead of setting YD equal to YL, you had plugged in the short-run aggregate supply curve, you would have gotten the same answer because when you're in long-run equilibrium, the SRAS curve is equal to the LRAS curve. But now that's not necessarily true. We will show you that in a moment. All right, so we've plugged all of this in. Let's simplify a little bit here. Now just moving this over to this side, we get 5 equals 2 times the rate of inflation. And so now $2.5 is the rate of inflation. And so this, again, is how you know that you are not in long-run equilibrium, right? Because if I take 2.5 and plug it into here, we'll get that this term doesn't vanish, right? So this is long-run aggregate supply, and we'll get that short-run aggregate supply is not equal to long-run aggregate supply. What is it equal to? So now, since we are in short-run equilibrium, we can no longer just use the long-run aggregate supply curve, right? That's what we did up here because we're in long-run equilibrium. In short-run equilibrium, you have to actually use the short-run aggregate supply curve. So I'm just going to take the short-run aggregate supply curve and plug in 2.5 because that's the equilibrium rate of inflation. And so we get 2.5 minus 1 plus 4, better known as 5.5. So what is happening here? So stepping back from the math, what's the intuition? The intuition is that, so the central bank has decided to raise the rate of money growth, and firms were not expecting that. Right, so this created inflation. There's more money floating around, right? People walk into a surfboard shop, they have more cash than they did before, and now the surfboard shop thinks, oh, wow, there's this increase in demand for my product, I have to produce more surfboards. And so they are tricked into producing more, and so the rate of growth is higher than it was in the long-run equilibrium, right? Before we were growing at 4% per year, now we're growing at 5.5%, right? So we've been tricked into producing a little bit more. So what does this look like? We can graph this again by figuring out the inverse curve. So let me actually use this pen to make it a little clearer. So just solving for P. We get this is the inverse curve, and so we graph this up here. So what is the new short-run equilibrium? It's right here, right? It's where the AD curve intersects the short-run aggregate supply curve. Is that clear? And so the growth rate here is going to be 5.5, right, what we just solved for. The rate of inflation is 2.5. Everyone clear on that? This part? Yeah. Other questions? That was an easy one. So is everyone clear on where all this is coming from? Is everyone clear on the intuition of what's going on? Right? The math here is very simple. The hard part is understanding why we are using the curves we're using and what is actually happening in the real economy. Is everyone clear on that? Yeah. So she asks, why is the SRAS curve the same? So remember, the SRAS curve consists of two pieces here. So we wrote it in general. It's the expectation of inflation and the long-run aggregate supply curve. Now, the long-run aggregate supply curve hasn't changed, right? So this part is going to stay the same. And we're in a short-run equilibrium. And so in the short run, expectations do not adjust. So this part is staying the same as well. Now, that's not going to hold forever, right? So in a moment, we're going to talk about what is the long-run equilibrium and what happens to expectations. But in the short run, firms haven't had a chance to catch on to what's happening in the economy. So we talked about the intuition of that. The idea is that basically it's hard for them to tell whether it's an increase in demand. So there's this big increase in aggregate demand here. They don't know if it's a demand for their product or for demand for all products across the economy as a whole. So initially they behave as though it's an increase in demand for their product and they produce more in response, right? So basically initially neither of these two things has changed, and so the SRAS curve is the same. All right? Other questions? No? All right, so then we will move to the third part of the question, which is what happens in the long run. So let's put this over here, actually. So part 3 of this question is, what is long-run equilibrium? All right, so what is long-run equilibrium? How do we find long-run equilibrium? How did we find long-run equilibrium here? Right, so he says we should set YD equal to YL. So in other words, anytime we're in long-run equilibrium, that just means set aggregate demand equal to long-run aggregate supply, right? The key thing is that aggregate demand curve has changed, right? So we're not using this same aggregate demand curve. So we did this over here, right? This is when we found long-run equilibrium before. The difference is that we don't have YD anymore. We have YD2. Oh, you can't see that. YD2 right here. So long-run equilibrium, now we're going to set YD2 equal to the long-run aggregate supply curve. All right, so this side of the equation is the same, right? So when we did this over here, we had a 4 on this side of the equation. It's the same here because long-run aggregate supply hasn't changed. The real productive capacities of our economy haven't changed. None of the parts of the Solow model have changed. What's changed is the aggregate demand curve, right? We're printing more money, printing money faster. And so on this side, instead of having the old aggregate demand curve, we have the new one. Right? So now we just solve as usual. We move 4 to this side of the equation, the P over here. We get the new equilibrium rate of inflation is 4%. So before, remember, the rate of inflation was 1%. Now it's risen to 4%. All right? Now, what is long-run growth rate? How do we find that? How fast does our economy grow in the long run? Does the speed at which we print money matter for our growth rate in the long run? So it stays 4. So basically what he's saying is that in the long run, it doesn't matter how fast we print money. So at the end of the day, our long-run output is determined by long-run aggregate supply, right? This is always true. In the long run, growth rate is described by the Solow model. And so the way we have that here is through our long-run aggregate supply curve, which is 4, right? So what is this telling us? This is how we know. So basically, the real productive capacities of our economy haven't changed between over here and here. And so we know that since nothing real has changed, we can't really, there's no way to get free growth forever. Just because you print money, it's not going to make your economy magically grow faster. And so we know the growth rates have to be the same in these two cases. What's changed? All that's changed is the rate of inflation, right? And this is intuitive, right? We're printing more money. We have more pieces of paper floating around. That's not going to make us richer, but it will change the numbers we have to write on our price tags. And this is what this is saying. We have to increase those numbers faster because we're printing money faster. In other words, in the long run, money is neutral, one of our principles of money, and inflation is a monetary phenomenon. We can see that here because really we are creating this extra inflation persistently because we're printing more money, and we're printing it faster. All right, so that is the first part of this. Now we have to check what is the new SRAS curve. All right. I could answer that, but instead I'm going to ask you to answer that. Yeah, we're going low-tech here. All right, so what's the new SRAS curve? Let me uncover what we did here so you can just refer to that. All right, so remember, what is it that distinguishes the SRAS curve? We defined it right here. And think about what holds for expectations in the long run. Take another 30 seconds. All right. 5, 4, 3, 2, 1. Okay. So, what is the new SRAS curve? So, as I implied, you want to use the general expression, right? So, we're always going to start out with a general term, so unexpected inflation plus the long-run aggregate supply curve, right? Now this part, again, hasn't changed. It's still 4, right? And so we put a 4 over here. So the only thing we have to figure out is what is expected inflation. And so remember, we started out, the way we solved for this here, we said, okay, what is expected inflation? Well, in the long run, expectations are realized, right? So the inflation rate we expect is the inflation rate that actually happens, which we just solved for, right? It's 4, right? So that's the SRAS curve, right? How are we doing here? Oh, that's encouraging. So most people got this, a majority at least. We'll work through a few more examples, so those of you who are uncertain or not quite sure. All right. So any questions on that example? No? All right, we'll forge on to another one. So, actually, before I move on, just want to graph this. Let's graph this first. So we want to get an inverse curve here. So this is going to be, we just simplify this a little bit, and it turns out our new SRAS curve is just P. So I can take the inverse curve. It's really easy. It's equal to the actual curve. So basically what is happening here? So we have an increase in aggregate demand, and so remember we have this temporary increase in inflation. Now what happens? Firms catch on, right? So their expectations were originally expecting 1% inflation per year, persistent 1%. Now they realize prices are rising, they're catching on. It's not just an increase in demand for my product, it's an increase in demand for everyone's product. So we all realize everybody has to adjust our prices upward together, and we also expect prices to rise faster, right? We realize, okay, they're printing all this money, that means we're going to have faster price increases. So this SRAS curve is going to shift. And so what is it? Well, we just solved for it, right? Now, the other curves are the same, so it's just this curve over here, which I will draw in blue. So it's going to move through the, all right, this is going to be tough. All right, pretend that's a straight line. And so we have this here, it's intersecting at 0-ish. And the key thing here is that where is it intersecting? It's going to intersect exactly where the AD curve intersects the LRAS curve, right? So basically we have this shift upward here. All right, everyone, does that make sense to everyone? So again, we know we're in long-run equilibrium and everything as well because all three curves intersect at the same place. Make sense? All right. Now let's move on to example 2. So in this case, so we're starting out exactly where we started out before, right? So we have long-run aggregate supply, and in fact we have basically this first line is identical to this first line up here. And we even have the growth rate of the money supply. It's the same as it was initially up here, right? So our initial growth rate of the money supply is the same, but now we're given an expression for the velocity of money. Before we're just told, hey, it's 0. It's 0. Let's move on with our lives. Now we're told that the velocity of money is a function of what? It's a function of the growth rate. Or rather, the growth rate of the velocity of money is equal to this function of the growth rate of real consumption spending, real investment spending, real government spending, and real net exports, right? The aggregate expenditure ID is coming in here. This is telling us that the faster that households are buying things, the faster that firms are investing, more that the government is spending, the more that foreigners are buying for us, the faster that money will be moving through our economy, right? That's what's implied by the velocity of money. Now, we're told that initially all of these terms are 0, and so we're going to start out like that, and we're starting out in long-run equilibrium, but then we have a widespread loss of confidence, and that's going to cause consumption growth to fall, that's going to cause investment growth to fall, and now we're told that the losses are temporary. So what do we make of all of this? All right, so let me move this over to this side here. Here, let's do this. This is going to be hard, all right? Okay. I think that's the most I can keep together here. All right. Our example 2, part 1. So what is the initial equilibrium and the initial SRAS curve? All right, so we know that growth rate of the money supply is equal to 5. Now, what is the velocity of money? Well, it's this expression over here, right? So 8 times the growth rate of consumption. Well, we're told that the growth rate of consumption, investment, government spending, net exports is 0. So it's going to be, 8 times 0 plus 3 times 0 plus 2 times 0 plus 0, which is all 0. And so initially the velocity of money, the velocity of money is 0. So in fact, it's exactly the same as we had initially here, right? Right, we had the growth rate of the money supply at 5 and the velocity at 0. And so what is, the AD curve? It is simply the same AD curve we had before. We know that's got to be true because the money supply, right? I mean, we can do it out even if, just to make ourselves believe this. So writing out the quantity theory again, we see this is a 5 and this is a 0. And so what does this imply? That AD is just 5 minus P. Same AD curve we had before, right? What is the LRAS curve? Well, once again, we're told over here that this is the LRAS curve. It's the same as we had before. This is the growth rate of productivity, same as before. Growth rate of the capital stock, same as before. And so knowing all of that, we know that long-run aggregate supply has to be the same as before, right, which was 4. So what is the initial equilibrium? The initial long-run equilibrium, right? So if we have the same aggregate demand curve, the same long-run aggregate supply curve, what does that tell us about the long-run equilibrium? The same, right? We're setting the same curves. I mean, we can certainly set this equal to this, but we already did that before. So we just know what was the initial equilibrium before. Well, the way we do it, we set YD equal to YL, 5 minus B equal to 4. That's the same curves as we had before, and so we're going to get the same answer as before. So we have the same as before. That's great. What does that tell us about the initial SRAS curve? Same. Why is it the same? Anyone? So if we start out in the same long-run equilibrium, why do we know the SRAS curve has to be the same? Where does the SRAS curve come from? This, right? So what's this? It's 4, right? It's the same as before. And what's this? If we're in long run equilibrium, what is expected inflation? Right? Expectations are realized, it's actual inflation. And we know from before that's 1, right? And so if you start out in the same long run equilibrium, you must have the same SRAS curve, right? So we have the same SRAS curve. Everything is the same, in other words. So initially, everything is exactly as it was before, right? So that's easy. Now, the interesting part, when does it get interesting? It gets interesting when we allow for this loss of confidence, right? So now we're saying that suddenly consumption is growing at negative 1% per year or shrinking at 1% per year. Investment is falling at 2% per year, right? So what does this mean? So the first thing we got to do is look at what's happened to our curves again, right? So what has happened to our curves? How do we figure this out? Well, so this shock in consumer confidence, we haven't been told anything about a change in M, and so we're going to say it's the same, right? The Federal Reserve, the central bank hasn't changed anything, and so rate of money growth is exactly as it was before. But what about the velocity of money? Remember, the velocity is a function of consumption, investment, government spending, and net exports, and that's changed. So we have to go back to our original equation, which we're given over here, and plug in these terms. So this is 8 times consumption growth, which is negative 1. 3 times investment growth, which is negative 2. 2 times government spending, so that hasn't changed, right? We've been told there's a change in consumption growth and investment growth. Nothing about government spending. So we can assume that stays the same. Nothing about net export, so that stays the same. So these are 0. It's just that we have negative 8 plus 3 times negative 2, which is a negative 6. And so we get over here a negative 14, right? So the velocity of money has fallen to negative 14. Velocity. So basically what the saying is that the rate at which money is moving around our economy is decreasing by 14% per year. So what's the new AD curve? Where do we get the AD curve from? Quantity theory, right? So as always, rate of inflation, growth rate of GDP is equal to growth rate of the money supply plus growth rate of the velocity. On this side, M is 5. Velocity is negative 14. So now we just solve. So this is negative 9. And so just moving this over to this side. Get that the new demand curve, I'm going to put a 2 here. Negative 9 minus P. And so what does this look like? So what are the curves initially? They're exactly the same as before, right? So at LRAS, we're here at 4. The initial aggregate demand curve, remember, was 5 minus P. So the initial inverse curve was this, right? And the SRAS curve initially was the same as before. Remember that it was, so this was the inverse SRAS curve. It's the same as just in the previous example, so you can just refer back to that. So, as always, these miraculously cross all at the same place. Right, and this is the initial equilibrium, right? So we have here, this is 1, this is 4, right? That's things before. Right, now we have the shock to aggregate demand, right? This decrease in consumer confidence and investor confidence. And so this leads to a decrease in the velocity of money. So consumers are not buying as much. So this is kind of like the example where we started out at the very beginning, where people just are less willing to spend, walking away from the shops. And so now we have, all right, I'm going to have to expand the axes out just to be able to draw this. So to get this in inverse form, we just move the p over to this side, the y over to this side. Like that. It's not too tough, but here we have a -9, and so it's, oh man, this is going to be ugly. This is the new AD curve. And all right, now where on this diagram will we find short-run equilibrium? What's the new short-run equilibrium? How did we find short-run equilibrium in the first example? So if we find long-run equilibrium by setting the aggregate demand curve equal to the long-run aggregate supply curve, where do we find short-run equilibrium? Yeah, we set the AD curve equal to the SRAS curve. So basically we want to find this point right here, right? This is the short-run equilibrium. So what is that? So see, this was part 1, that was part 2. So short-run equilibrium. So we're going to take the new aggregate demand curve equal to our SRAS curve, right? Short-run SRAS curve, short-run aggregate supply curve. So this is, we just solve for it, -9 minus p. And the SRAS curve is right here, rate of inflation, -1 plus 4. And now just algebra. So over here we have p plus 3, 9 minus p. So move the p over to this side. So 2 times the rate of inflation. Move the 3 over to that side. We have a -12. So we get that the new rate of inflation in short-run equilibrium is -6. Right? So what is this? It's -6. And what is this? We get that. How do we find that? We can just take equilibrium, -6, and plug it into either the AD or the SRAS curve. I'm just going to stick it in the SRAS curve. So -7 plus 4 is just -3, right? So this is -3. All right, does that make sense to everyone? Are there any questions on any of those steps? So what is the intuition here? So basically, we have a decrease in consumer confidence. Households are buying less stuff, or they're buying it more slowly, they're cutting back. Firms are buying less, we have less investment, and so we have this big decrease in aggregate demand. Now, the firms in the economy observe that households and other firms are buying less of my stuff. They don't realize it's a shock to aggregate demand. They just think it's a shock to their demand, and so they cut back on their production. Everybody does this, and so we have a decrease in aggregate output. And so we fall down here. We are tricked into producing a little bit less. Now, the question is, what happens in the long run? Now, the key to figuring this out is to read the question carefully. Both losses of confidence in households and of firms, they're temporary. What does that mean? So the way we should interpret that because the loss of confidence is temporary, we know that let me say, in the long run, growth rate of consumption returns to its original state, right? It was originally not growing, and so we know it'll eventually go back to what it was before. The growth rate of investment will go back to what it was before, right? And the key thing, the reason why we know that is because these are temporary losses of confidence, right? So because we have temporary losses in confidence, what does this tell us? Well, sorry? Well, it tells us that in the long run, our aggregate demand curve will go back to what it was before. So in the long run, either way, it wouldn't matter, right, in terms of growth rate of GDP. The question is, which curve is shifting, right? So before, in the example we saw before, what happened? We saw that in the long run, the SRAS curve moved, right, because firms adjusted their expectations. But in this case, this loss of confidence is temporary. So in the long run, consumption growth will fall back to what it was before, investment growth will fall back to what it was before, and so the velocity of money will fall back to what it was before, right? We'll go back to the case that we had initially over here, right? So the velocity will go back to being 8 times 0 plus 3 times 0 plus 2 times 0 plus 0, which is 0, right? So in the long run, what's the AD curve? It's what it was before, right? It's the same thing here, right? Because the velocity is the same, growth rate of money supply is same, and so AD in long run is the same. So our new latest AD curve is just the same as our first AD curve, which is 5 minus p. Now, what does that tell us about the long-run equilibrium? We have the same AD curve as before. We have the same LRAS curve as before. What must be true about the long-run equilibrium? Yeah, they're the same, right? The same curves. The way we find long-run equilibrium is by setting, right, LRAS equal to AD. If they're the same, then we're going to have the same equilibrium. And so, in other words, in the long run, everything will be the same as before. So we have the same AD curve, the same long-run aggregate supply curve. That wasn't going to change anyways. And the short-run aggregate supply curve will also be the same as before, right? And so What is the growth rate of GDP? Well, it's the same as we had before, right? And so how does this look on the diagram? Basically, we had the AD curve. It initially shifted down like this because of the loss in confidence. And what's going to happen now? Well, it just shifts straight back, right? Why is this? We regain confidence. So the key distinction there, what tipped us off, was the fact that we said this was temporary. Let me see if it's... All right. So... So basically, if there's a shift in aggregate demand, and we're in a short-run equilibrium, now we have to move from the short run, right? The short run can't last forever by definition. We have to get back to long-run equilibrium. So how can that happen? Either because SRAS shifts, in other words, because expectations adjust, or because aggregate demand shifts back, right? And we saw both of these examples. So the first time we saw what happens when aggregate demand stays where it is because of a permanent change in the growth rate of the money supply. And what happened to short-run aggregate supply? It shifted because expectations adjusted. Firms started expecting faster inflation, and so the SRAS curve moved. The second example we saw was the second case, where AD simply shifted back. How did we know that? Because it was temporary, right? And so this is what keyed us off. The consumption growth temporarily falls to -3. Central bank permanently raises to M. This is the distinction, right? When you have a temporary shift, we know that AD will shift back, right? It's not going to last forever. And so firms won't adjust their expectations because that's not the new long run, right? You know, they're caught off guard temporarily, but it's a temporary change. It goes back to things the way they were before. On the other hand, if it's permanent, and we say explicitly, so if this were an exam question, we would make it very clear, temporary change in this, permanent change in this, that's how you know what's going to happen in the long run, right? So if it's temporary, AD will just go back to what it was originally. If it's permanent, then SRAS will shift. AD will not shift back. AD will stay where it is. And so how do we get back to the long-run equilibrium? We get back because the short-run aggregate supply curve will shift. All right? Is everyone clear on that? Any questions? Please do not hesitate. Yeah, over in the back? No, he's gesticulating. Fair enough. Questions, though? All right. So let's just think. So in this case, we said this was a temporary change, right? Let's suppose if it were a long-run change. Oh, he has a question? In this example? So oops, let me just move this over here. So remember that, so initially we're in the long-run equilibrium, right? So did you get where it came from there? Yeah. Okay. So basically the point is that in this case, the AD curve shifted back, and so we have the same long-run equilibrium. So the long-run equilibrium is the same. We have the same inflation rate in the long run, and so it's got to be the same expected inflation, right? Other questions? So in this example, we considered the case where we had a temporary change in the loss in confidence, right? So let's suppose that it had been permanent. what would the long-run equilibrium be? Suppose that the shock we had before were permanent. So this AD curve that we solved for and found right over here, let's suppose that were permanent. So what would be the new long-run equilibrium? Which one? All right, so this is the example we had before. All right. So this is the new AD curve. Oh, this is what you want shifted up. Very good. I'm going to turn the multiple choice into a short answer. All right, so think to yourselves, how do we find long-run equilibrium? All right, so we have a permanent change, permanently new aggregate demand curve. Now, this is the AD curve. How do we find long-run equilibrium, right? So we've done this twice, at least now, I think. So we have a very general way to do this. So how do we do it? Take another 30 seconds. All right, 5, 4, 3, 2, 1. All right, so I see a few people assumed the earlier quiz was the only one. Bad move. All right, so how do we do this? So how do we find for the new long-run equilibrium? Well, we have a very set method for solving for long-run equilibrium, right? It's that we take aggregate demand and we set it to the long-run aggregate supply curve, right? This is our general method. Now, what was our AD curve? Well, we said this change is permanent, and so this must be the AD curve, right? So it's AD2. 9 minus growth rate of inflation is equal to LRAS. LRAS has not changed at any point in this, right? The real productive capacity of the economy hasn't changed. Sorry? Oh, yeah, sorry. Good catch. The first step is to write down your curves correctly. All right. So set these equal to each other, and now it's just algebra, right? I don't think at this stage anyone's having any issues. So move this over to this side. We get a negative 13. So in equilibrium, the rate of inflation is negative 13. So we have deflation of 13% every year. What is the growth rate of output? This you don't have to do any algebra, right? Because we know that in the long run, output grows at the rate determined by the LRAS curve. Y star is equal to YL equal to negative, to 4. And so we know that it's actually got to be D, right? And all right, so we'll continue on with a few more examples like this. And a lot of people did here.
I have a question. So since we have a shift in interest rate growth, shouldn't we also be switching the SRAS curve since it's